All right, so let's go ahead and finish lesson 5 today. Just to remind you what we were doing yesterday is we're trying to answer these questions about how much percent is one thing of another or whatever, using this idea of manageable chunks, which is just what I'm calling the factors of 100, because if you know how much 5% of something is or 10% of something is, it's relatively easy to figure out what 100% is. And so they're chunks of 100%, but they're manageable. Um, so what I want to do today is I'm going to do question number 3 here as one more example to sort of like refresh your memory of what we were doing yesterday. But then I need you guys to try this stuff. So we're going to go to the last 2 questions of the lesson afterwards. And for both of those, I want you to do it first without doing... Try not to do the algebraic way where you just like divide or multiply by a decimal. I want you to try like figuring out the right chunk and then multiplying to 100 from there, like using the strategy that I do. And so I'm going to ask you to pause, do this one, then check your work against me, then pause and do this one and check your work against me. But let me do this one first as an example, and then we'll get to that. All right, so this one says, Kurt has driven 276 miles of his road trip, but still has 70% of the road trip left to go. So he's going super far, right? If he still has 70% of the trip to go, that means he's only gone 30%, which is about a third. So he's driven almost 300 miles and he's only a third of the way there. So he's driving like 900 miles. That's so the answer, like the question is, how many more miles does Kurt have to drive to get to his destination? I'm saying that the trip itself is going to be about 900 miles. So I'm thinking he has about 600 miles left to go. So I'm sure that's not the exact answer, but we should expect to get an answer close to 600 when we're done with this question. So I'm going to do it the same way I've been doing it. I'm going to make 2 number lines, one that represents sort of like the actual numbers in the question, and then one that represents the percents involved, and that helps us sort of like match things up. So I'm going to make a number line, la 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 la, and it's going to represent like the actual miles. And so obviously when he started, he had gone 0 miles. When he finishes, he will have gone the whole trip. That's something we don't know yet, so I'm just going to write whole trip. I'm kind of messed up there. And then it says he's gone 276 miles, and that means he has 70% of the trip left to go. So just by doing a quick 100 minus 70 in my head, I know that means he's only gone 30% of the way. So 30% of the way is about here-ish. So I'm going to put 276 right there. All right. And so now let me make another number line that represents the same information, but as percents. So if you've gone 0 miles, you've gone 0%. And if you've gone the whole trip, well, you've gone 100% of the way there. And we know that 276, that's 30%. Okay, so percent of trip is what this line will represent. All right, and so now let's see if we can take this information that 276 is 30% and turn it into a manageable chunk. That's a factor of 100. So we can't really take that 30% and turn it into 25. There's no good way to do that. We can turn it into 10 though. Like it's easy to go from 30 to 10. You just divide by 3. So let's do exactly that. I want to take 30% and make 10%, which would be right about here. In order to do that, I need to divide by 3, right? And so that means that I got to do the same thing up above. If I want to take 276 and find out what 10% of the trip would be, I need to divide that number by 3. So let's do exactly that. 276 divided by 3 equals 92. All right, so I'll put a little mark here, try to keep it even with the 10%. 92 miles represents 10% of his trip. And so now, if I have 10% and I want to know 100, well, in order to go from 10 to 100, that's times 10. And so I got to do the same thing here. If I want to go from 92 miles, which is 10%, to the whole trip, which is 100%, I got to multiply by 10. And so we're doing 92 times 10 equals the whole trip. I could grab the calculator, but you should know that when you multiply a number by 10, you just slide everything over one place and add a 0. So instead of 92, we will have 920. I'm going to put a 920 right here. But we're not done yet, right? Because the question didn't ask how long is the whole trip. It said how many more miles does Kurt have to go. So we just have to take one extra little step, right? If the whole trip is 920 and he's gone 276 of it, then we need to go 920 minus 276 equals, well, let's see here, 920 minus 276, 644. So that's kind of close when I was guessing earlier, right? 644, and I'll just finish the question up by writing 644 miles left to go. Boom. All right, so hopefully that was a decent reminder of what we're doing here and how we're doing. I just realized I was off the screen a little bit. Now you should be able to see everything. So now I want you to look at question 4 here. Hopefully you can read it on the screen. If you can't, that's why you're supposed to always have the e-copy of the book. And practice doing this one using this sort of strategy that I've been showing you. Okay, so I'm assuming you're pausing the video now. You're going to do question 4, and then you're going to check your work against me when you're done. Okay, so you should be coming back from pausing and doing question 4. That shouldn't have taken you very long because question 4 is super easy because they give you a manageable chunk off the bat, right? They gave you 25%. So let's read the question. It says, Derek had a .250 or .250 batting average at the end of his last baseball season, which means that he got a 25%. He got a hit 25% of the times he was up to bat. So that's what those batting averages mean. When you're watching baseball or whatever, if they say somebody has a 312 batting average or something, they usually just say the number, not even the decimal point. Like that would be a .312. And if you convert that to a percent, that's 31.2. So if they say, oh, he's got a 312 batting average, which is really good, that would mean that he's getting a hit 31.2% of the time. So a 250 batting average, that's 25% of the time. So let's make 2 number lines that go with this, all right? We'll make a number line that represents his hits just in actual numbers. So hits, he could have 0 hits and he could have all of his hits, but we know that oh wait, no, I was about to mess this up a little bit. It says that he got 47 hits last season, so that actually is his all. We know that number. It's 47, should be way over here. And it says that he got a hit 25% of the time. And so how many times did he bat? Oh, okay. I'm messing this up. This number line, we don't want it to represent his hits. We want it to represent the bats. The number line should always represent the thing that you're trying to figure out. And I got confused. I thought I was trying to figure out number of hits, but we're trying to figure out how many times did he get up to bat. And so I'm going to recross this out again because I was right the first time. We want this to be all at bats over here at the end of this number line. Okay. And then we know that 25% of his at-bats were hits. And that's the 47. So we can put a 47 25% of the way along this number line, which is approximately here. So I'm going to put a 47 right here. All right, now I think we got it reasonably set up. And I'm going to make another number line. That's the same thing. It's bats again, at-bats, I guess I should say, but it's in percents. So 0 hits would be 0% of his at-bats. If he hit every single time he was at bat, that'd be 100%. And the 47 hits he did get, that represents 25% of his at-bats. And then normally what we would do here is try to find a manageable chunk that we could work with and that we could move to 100% with. But you didn't even really have to do that with this question, right? 25% is a manageable chunk. 25 times 4 is 100. And so that just means if we want to figure out how many bats he had, just do 47 times 4. So this was a pretty easy one. 47 times 4 equals, what is it, 178? 188. 188. So let me write a 188 over here. And I will write Derek batted 188 times. There it is. All right, same thing for question 5, please. Either you can read it here on my screen or you're looking at your e-copy of the book, but I want you to try this question for a couple minutes using this sort of strategy. If you didn't wind up writing all these number lines and stuff, if you were able to do the last question just like you immediately knew you were supposed to just multiply by 4, then that's totally fine. Like, you don't necessarily have to write all this stuff. But use this strategy in whatever way works for you to see if you can answer number 5. You are pausing the video now. You are doing that. And then you're going to unpause it when you're done. Okay, so hopefully you did that. Hopefully you paused the video and you've got your answer for number 5. And now let's check it against mine. It says Nelson used 35% of his savings account for his class trip in May. If he used $140 from his savings account while on his class trip, how much money was in his savings account before the trip? Okay, so let me kind of talk my way through this one before I draw all these number lines. $140 is 35% of the money he had in his account. And I'm trying to figure out how much money he had total before the trip. If they're giving me 35% and I want to try to find a manageable chunk from that, I don't think I'm going to get 25%. I don't think I'm going to get 20%. I'm not going to be able to get 10% either, but I can get 5% because 35 divided by 7 equals 5. And then that means that I'm going to have to multiply by 20, right? If I go from 5 to 100, I have to multiply by 20. And so I think the answer is going to come from taking this number, dividing it by 7, and then multiplying by 20. Right? That's probably going to be the strategy we're going to wind up using, but I'm going to draw the number lines anyway because I'm a teacher and that's what we do. So let's see here. This number line will represent his money. And he could have $0, or he could have all the money in his savings account. And we know that $140 represents 35% in his account. And 35%, well, if this is half, then 40% would be about here. So maybe 35 is like here. Okay, so this is $140. And now let's make a percent number line to go with this. Let's see here, I'll use the green. And so this will be money, but in percents. And so he could have 0% in his account, and he could have 100% of the money in his account. And we know that this 140, that's 35% of the money in his account. And so we need a manageable chunk to work with. And I think our best bet in this case is to make a tiny little chunk of 5%. Because we can take 35 and divide it by 7 to get 5%, which means we have to do the same thing up here. We take this 140 and we divide it by 7, and we get, hopefully I already did this, you should know what I'm going to get. 140 divided by 7 equals 20. So $20 is 5% of what he had in his account. Then, if I want to go from 5% to 100%, I got to multiply by 20. So we got a couple different 20s going on in this question. We're going to take this 5% and multiply by 20 to get 100% of the account. And so we got to take this 20 and multiply it by 20 to get how much money he had in his account. 20 times 20, that's an easy one because you just do the 2 times the 2, you get 4, and then you got 2 zeros in there. So it's going to be a 4 followed by 2 zeros. So he had $400 in his account to start with. He had $400 before the trip. All right, so that's the end of lesson 5. I'll show you the exit ticket for a second if you want to try it. Oops, that's the lesson summary. Okay. If you want to try this one, go ahead. I don't know that I'm going to go over it or anything though, but if you're the type of student that just really wants to try and do those and I'll do a little extra, go for it. All right, see ya.